change and start values. We're on page 61, which is lesson 2.4 in your book. And rate of change is what we have called the operation so far with recursive routines. We're just going to change our vocabulary a little bit, but the idea is the same. So now when we say rate of change, we mean the same thing as operation. Unfortunately, sometimes we're given a problem, like in example 1a, where we can't see the operation immediately. It's like we're given just part of a recursive routine. Like let's say after the operation has been done 20 times, and we need to know what one operation is. So we're not given necessarily a start value or an operation. We're just given a picture of it. Like, for example, example 1a, Jessica loses $580 in 20 days on the stock market. And we want to know what is the operation just for one day. So what we do is set up a rate minus $580 for 20 days, and we're going to divide both numbers by 20 to reduce it to how much she loses for just one day. And this is our operation. This is our rate of change. So our start value is $580, and the operation is minus or subtract 29, because 580 divided by 20 is 29. So if we write this out in a recursive routine, we would just keep subtracting 29 each time. So 580 minus 29 is 551. 551 minus 29 is 522, and so on. So we were given just $580 in 20 days, and we weren't given how much she would lose each day, and we had to figure that out. Okay, for example 2, Patrick earns $53 for delivering 10 packages. Now, there's a mistake here, and I want to see if you can figure out what the mistake is. And if you're going over this in class with me, we're going to see if you can find the mistake. We actually do know what the start value is. He hasn't earned anything if he hasn't delivered any packages. But we're going to try to figure out the operation. So if he earns $53 for delivering 10 packages, our operation is how much he's going to earn delivering just one package. And there's the mistake right there that we'll see if you catch if you're watching this with me in class. I substituted days for packages. So I have the wrong units. I'm doing the right thing, dividing by 10, and it's $5.30, not per day, but per package. So we'll see if you catch that mistake when you're doing this in class. So the operation is not per day, but per package. So there's a couple of mistakes on example 1. Now I want you to write in your notes that the rate of change is the change in the y values compared to the change in the x values. This is going to be a rather important idea. So, and then make a XY chart, and I'm color coding, and if you want to get some color, I have yellow are my x values and pink are the y values. So the change from one set of points to the next is what we're looking at, and it doesn't matter which set of points you use. So I chose the point 0, 3. That means after at x equals 0, y equals 3. This, by the way, is not go with example 1. This is just a random example of sets of points. And the point where x is 1 and y is 6. So I find the difference in y values. 6 minus 3 is right here, and the difference in x values, 1 minus 0, is right here. So the rate of change in this table is 3 over 1. Every time the x value goes up 1, the y value goes up 3. If we had this in a recursive routine, it would be simply add 3. So the rate of change is the change in y values divided by the change in x values on a table. Okay, so here is a table for you to copy. You might want to hit stop on the video and just copy this down. There is no story that goes with this. We just have x values from -1 up to 3 and y values from 1 up to 13. And we find the change in y values, x values, goes from 0 to 1. So that is 1 right here. And at the same time, the y value goes up 3, from 4 to 7. So that's right here. Again, I'm going to use color to help organize the information. So 7 minus 4 is a change in y, and 1 minus 0 is a change in x. So that's where they get that 3. The start value would be 4 because that's the y value when x is 0. And the operation is going to be add 3. Again, the start value is 4 because that is the y value when we haven't done the operation. So remember, x is how many times have you done the operation, and this 0 says I've done it no times. This is I've done the operation 1 time, 2 times, 3 times. on example 3, we're given the x values, 0, 1, 2, and 3, but it looks like the y values got kind of messed up, and all we can see is a 6 and a 4 right here, a 6 and a 4. So we're going to have to try to fill that in. It kind of got messed up. So we can find the rate of change by finding the difference between the y values and dividing that by the difference in the x values. So 3 minus 2 is the change in x, and at the same time it goes from 4 to 6 on the y values. So we can use this information to fill in where the table was destroyed there and we couldn't see what the numbers were. So it looks like it's dropping down 2. Our operation is subtract 2. So we can work backwards to fill that table in. And there's another mistake. There's a second mistake. So this should not be a 4. This should be an 8, and this should be a 10. So for example 3, if we look in the book, that should be an 8 and a 10. So there's our second mistake. All right, let's go to the last example. Example 4, make a table. And we're going to make a gigantic table. In the book, for example 4, you see only 1, 2, 3, 4, 5 rows. But I've made about 15 rows because we're going to fill all those missing numbers in. So you might want to stop the video right here and fill in or make a table that's this size. And again, I'm going to color code the x values and the y values, and we have to find a rate of change. So the change in y divided by the change in x is going to be our rate of change. That's going to be the clue that we need to fill in the rest of the table. You can choose any two numbers, or any two sets of numbers. So I'm going to choose the 3 and the 11, the 7, and the 27. This gives me an operation of add 4. So now I can just add 4 all the way down the column. And the most important one on the entire table is going to be right there. I circled it, 0 and -1, which gives me a start value of -1 and an operation of add 4. That's what we're always looking for from any table, is the start value and the operation.